Well, folks, welcome back. This is Dave with Wyoming Old Iron, and today we're continuing our series on microwaves. Now, we're going to get into no heat, but before we do that, this is where safety becomes really important on microwaves. Right here we have what's called your high voltage capacitor. That's that big long silver thing that's oval shaped. It stores between 2,000 and 3,000 volts. And it is very painful if you discharge it through your body. So and I have not had this microwave on and heating since it was grounded, but it is very important you ground out that capacitor. Take an insulated screwdriver, a very well insulated pair of pliers, and simply go across the two sides. If it's charged, you'll get quite an electrical snap there. So anyway, what we're going to do today is we're going to cover microwaves that run and don't heat. And this is probably one of the most misdiagnosed and messed up things on microwaves. So the first thing you have to do, if you're unsure of what's going on, is you have to determine if the problem is a high voltage issue or a low voltage issue. So here we have what's called your high voltage transformer. You see the orange and white wires in, that's what's called your primary. Over here, you see the two white wires with the red wire. That's your secondary and your filament voltage. In order to determine if you have a high voltage or a low voltage problem, meaning is the problem in the high voltage side over here on the left, or is it in the 120 volt side over here on the right, the easiest way to tell that is to determine if you have 120 volts into this transformer. So what you do, and I'm going to try to get this set up, and this may not go real well, we'll find out. Hoping that I can get the meter in here. Now, see, that's going to block the view. That doesn't show you the... Okay, so you're going to have to take my word for it, unfortunately, on the meter. That's the one thing I wish I had a really good setup here, but I don't. So what you're going to do is make sure you have something in the microwave. I've got a cup of water in there. And you're going to see if you have 120 volts to that transformer. Okay, I've just turned the microwave on. You take your meter leads, and for the subject of today's video, I have 120 volts. So that tells me that my problem is in my secondary voltage. So now what I'm going to do, I'm going to reset the camera, and we're going to show you how to check for no heat on a unit that has a secondary voltage problem. That's your high voltage transformer, your diode, your capacitor, and your magnetron. So let me get the camera set back up. Okay, folks. So we're going to, this video is going to cover high voltage microwave components. So what we're going to assume is you have a complaint of runs and no heat. We're going to assume that you've checked here on your transformer primary voltage side, and you have 120 volts there. So now let's discuss each component in turn. If you have a unit that runs and you do not get a really, really, really loud, high-pitched hum out of it, then you can safely assume a couple of things. You can assume that the capacitor is probably good, and you can assume the diode is probably good. So let's discuss. The diode has a very high resistance, only lets power through it one way. Diodes, I've only ever seen them fail by shorting out. When they short out, the microwave will have a loud, loud buzz and will have no heat, but you'll have the 120 volts into the transformer. That will almost always be a diode, and I'll explain why. If you have a high buzz and it's the capacitor, it will almost always blow the fuse. So if you go out on a unit that's running and not heating and has a loud buzz, it does not blow the fuse, it is not your capacitor. Do not order all 4 high voltage components. Your capacitor is not your problem. Now, occasionally, you will get a quieter buzz, if you will, on the magnetron, which is that little guy right there. So, when you suspect a magnetron, there's a very easy way to check it if you're getting a buzz. Okay, so the first thing I want you to do is I want you to hear the magnetron draw in. I'm hoping this thing will cooperate. It's very, very tough to hear. If there's a secondary hum that comes in, and it's very, very minor. In case you're wondering, it is heating. I've got 15 amp draw. Okay, so I'm going to stop it. So I don't know if you could hear the difference when the mag was in and when the mag wasn't. It's very, very quiet difference. But let's assume you have a unit that's buzzing and is not heating. So the first thing to do to prove whether or not it's the magnetron is simply unplug it. And it's being cantankerous here. Okay. Now, if you turn this on and your buzz disappears, you know it's a bad magnetron. That's the reason you're not heating. Having said that, that's not the only reason why they won't heat. You can have them run and not heat and not make any noise. Again, let's assume it's running, it sounds normal. Come back here. You got 120 volts there again. So now, you don't have any noise at all. Second thing you check is the magnetron for continuity. And you can have a, it's not common, but you can have an open magnetron. So, see if we can get the meter in here. This should have almost 0 ohms on the magnetron. If the coil is good here. It has a little bit of resistance, but very little, usually about 1/10 of an ohm. And it's very, very difficult to do this one-handed. Okay, so yeah, it's 0.2 ohms, 0.1 ohm. Okay, that is telling me your magnetron coil is good. And again, you won't find an open one terribly often, but you do occasionally. So now, the next one, it's very rare also to have a bad high voltage transformer. But it does happen. So we're going to discuss how to check for filament voltage. A microwave uses 2 voltages to produce the heat. It uses the high voltage of 2,000 to 3,000 volts, and it uses the what do I want to say? And it uses the 3 volts AC filament voltage to energize the coil on the magnetron and excite it. It excites it. That's what energizes your heat. If you don't have your 3 volts AC, unit won't work. So, having said that, loose connections on the magnetron will cause no heat. I've got a piece of metal back here. It's causing the camera to wiggle. Okay, so let's discuss how you check for filament voltage. And this is one a lot of techs don't know, but it's a very important test. So you come down here to your transformer, or to your capacitor, I'm sorry. Or, well, to the transformer. Let's do it that way. Now you see you have 1 red wire and 2 white wires. The 2 white wires that are the same color will be your high voltage leads. Or excuse me, I'm sorry, I'm saying this all wrong. Will be your filament voltage leads. The wire that's by itself is usually a different color, comes off of a different area of the transformer a lot of times. That is your high voltage lead. And you'll notice it comes over here to the capacitor, and it's all by itself on the capacitor. The wire that is by itself on the capacitor is always the high voltage lead. So we're gonna pull this off the cap. Okay, so you've now there goes the camera. You've now disconnected your high voltage from the heating circuit. So the unit won't heat, but you still need to check for that filament voltage. So what you do now is you bring these 2 magnetron wires out that are disconnected. You take your meter, you put it on volts alternating current, AC. You do this, and I'll be back with you momentarily. Sorry about the interruption, folks. I'm actually filming this while I'm working, and these videos will be sent to the gentleman I work with who shoots the videos for my company. And he has a full studio and can shoot videos much better than I can. And he's going to use my videos as the basis for shooting videos for our company on this unit. So anyway, so I had to take a phone call. But anyway, so what we're doing now is we're checking for that 3 volts AC filament voltage. To review, high voltage leads disconnected. You got your meter leads in, and you're looking for 3 volts AC. So we're going to come up here. start. And you'll notice we have 3.75 volts. So we have filament voltage. So that tells you that the filament side of your transformer is good. So at this point, you've eliminated everything else. You have a good, you know you got power into the transformer. You know you're not getting any loud hums from a shorted diode. You can check for an open diode, but you have to have a really, really heavy-duty meter that uses a 9-volt battery. And in my whole career, I've seen one open diode. You know it's not the capacitor. And again, in my career, I've seen one open capacitor. You can also check for that. When I say open, I mean there's no electrical path through the component. So at this point, and you know you have 3 volts AC filament voltage. At this point, the problem is 99.9% likely to be your magnetron tube. So I'm going to drop the magnetron out, and I'm going to show you something you need to check for. That I have seen on this model 5 or 6 times, but I've seen it on all microwaves over the years. You can have a bad magnetron to the point where the unit's not repairable, but I want to show you that. But I don't... Oh, there's a Phillips screwdriver right there. So we're going to take loose this airflow director here. Okay, we're going to leave our leads disconnected. There's 4 Phillips screws on this particular model that hold the magnetron in place. So, here's your magnetron. Gets its name from the 2 magnets that help it produce heat. That's the top magnet, that's the bottom magnet. Okay. So, for the purposes of this discussion, we're going to talk about this little guy right here. This is called your antenna, or your magnetron antenna. This, occasionally you'll drop this magnetron out of there, and this will be all discolored, burned up, may even be melted. If that's the case, not only is your magnetron bad, but this inserts up into what is called the waveguide. Microwaves produce microwaves, hence waveguide. That's this piece right here. Directs the microwave radiation into the cavity. So it's very tough to see it, and there's no way I can get it on camera with my camera equipment. But there's a hole up in there where you can look and see if that antenna has been burned up, if the antenna is burned up. If that waveguide is burnt, the unit is not repairable at all, and you will have to replace the entire microwave. And again, with this model, I've seen it half a dozen times, so it's not unheard of. So that pretty much covers the no heat on a microwave, assuming power to the transformer. Again, in 32 years, I guess, it has only ever been the magnetron or the diode probably 99% of the time. It is, again, assuming 120 volts to the transformer. It is so rare for it to be the transformer or the capacitor, again, assuming it runs and does not heat, that it's virtually not even worth doing. But if you don't know what's going on, don't order those parts. You don't need a high voltage transformer in all likelihood, and it's very unlikely you need the capacitor if the unit runs and doesn't blow a fuse. Again, we're talking once in, I'm probably going to guess 5,000 microwaves over my career, and that may be a light number because we used to do 10 or 15 a day in the shop. when I worked in a shop where people could carry them in back in the days when microwaves were worth something. So with that note, that covers your bad secondary voltage on your microwave. If you guys think you're learning something, please hit that subscribe button. And I will be getting back to the McCormick Deering 6 horsepower engine here shortly. I've got some stuff on order for trying to get that head off if you've seen that video. Thanks for watching.